We are on inscribed angles, which is part E and the bottom of page 15. At the top, you see a blank circle. I'm going to go ahead and draw a inscribed angle for you. An inscribed angle has the vertex lying on the circle and chords extending from that vertex. So the angle I just drew is an inscribed angle, and the arc is called the intercepted arc. So this part right here is called the intercepted arc. Okay, what we will observe is that the intercepted arc is equal to twice the measure of the inscribed angle, or the inscribed angle is equal to 1/2 the measure of the intercepted arc. If I were to draw the central angle from this, you can see that the central angle, which is congruent, we learned in the last few sections that the central angle is equal to the intercepted arc, and we can see the central angle is wider than the inscribed angle, and in fact it is twice as big, just like the intercepted arc, in terms of angle measure as the inscribed angle. So I'm going to erase the central angle. So certain properties are true once we have that information. If I am given a circle and let me make that circle just a little bit bigger. If I draw two inscribed angles in that circle, I have that if those two angles, so that's my first inscribed angle, and my second inscribed angle shares the same intercepted arc, that means that they are equal to the pink and the purple angle are each equal to 1/2 of the intercepted arc. So our conclusion would therefore be that they are congruent to each other. Okay, the other property would be of what happens if I have a circle and the inscribed angle. So let's say you have the inscribed angle is a right angle. So what conclusion can we make if the inscribed angle is a right angle? The inscribed angle is a right angle, then we know that it is the intercepted arc is a semicircle. So if we know that the inscribed angle is in a semicircle, then we can conclude that the inscribed angle is a right angle, so that it's 90 degrees. Okay, and then lastly, if we have a quadrilateral that is inscribed in the circle, then the opposite angles within the quadrilateral are supplementary. So meaning angle B and angle D, as well as angle A and angle C as the other pair, are supplementary. So now using those properties, I'm going to answer 6 and 7 with you guys and have you do 8 and 9 on your own. So we can start in a number of area in terms of which variable we want to start with. We take a look at the picture and I automatically get drawn to the fact that x is an inscribed angle and I have the measurement of its intercepted arc being 160. So the intercepted arc is exactly twice as much as the inscribed angle, or the inscribed angle is 1/2 of the intercepted arc. So 160 over 2 is equal to 80 degrees. Okay, so if I'm trying to find out what z is equal to, z is the intercepted arc of this angle measure right here. And let me switch color, this angle measure. And that angle measure happens to be the third angle of a triangle. So if I take 180 and I subtract 68 and I subtract 80, I get 32. So if the inscribed angle is 32 and now I'm trying to get to the intercepted arc, since that's 1/2 of z, z should be equal to 2 times 32 or 64 degrees. And then lastly, the other angle that I'm trying to find out is y. And y happens to have the intercepted arc of, if I trace where it gets intercepted, it intercepts from there all the way around to here. And so that intercepted arc is the sum of 160 plus z, which we found to be 64. So that would get me 224. So the intercepted arc is 224 degrees. So therefore y is the inscribed angle, so I would have to cut that in half to get 112 degrees. Okay, on number 7, you see that you have an angle X and an angle Y, which intercepts a semicircle. So because it intercepts 180 degrees, we can make the conclusion that X and Y are right angles. So X is equal to Y degrees is equal to 90 degrees, which then leaves us with the fact that this is 180 degrees and that these chords are congruent. Okay, so if those chords are congruent, then their intercepted arcs are congruent to each other. So Z therefore must be equal to 90 degrees. Okay, go ahead and hit pause and try 8 and 9. Okay, with 8 and 9, I'm going to give you guys the answers, and then hopefully you were able to figure it out. So Z is 86 degrees, X is 35 degrees, and Y is equal to 70 degrees. Y is the central angle. And on 9, we have that X is 95 degrees, supplementary to 85 degrees, and Y is 70 degrees. It's supplementary to 110. And Z is equal to 140 minus 60, or 80 degrees. Now down below that, you have the measure of an angle formed by a chord. So the angle is formed by a chord and a tangent. So this is my tangent line. Actually, let's go ahead and switch colors. So the chord will make in pink, and then I'll highlight or underline that. And then the tangent will make in blue. So the angle that's formed by that is equal to half the measure of the intercepted arc. And the intercepted arc I will highlight yellow. So intercepted arc, it's half of this measure right here. Okay, so in the number 10, 11, 12, I'm going to go ahead and do that with you guys. On 10, you have that they are asking for the measure of CBD. The intercepted arc is 240 degrees. So if I want the angle measure that is formed by the tangent and by the chord, then I would take half of the intercepted arc, which is 120 degrees. The question then asks, well, what is the measure of arc BD from there? So if you know that arc CBD is, or not arc CBD, but the angle CBD is equal to 120 degrees, then the angle ABD is equal to 60 degrees, which if I then take that angle that's formed by the tangent and BD, so AB and BD, and double that, then I get arc BD is equal to 120 degrees. Okay, and then angle ABD we just figured out was equal to 60 degrees. It's half of 120.